Afternoon. As for my objectives, nothing has really changed yet, but hopefully be able to, as I progress with my project, I'll be able to add more objectives to it. Hence, I would just like to go into more depth on the existing methodologies that I've researched about. As I said, collaborative filtering is an approach to recommendation system that was proposed by Goldberg in 1992, wherein he stated that information filtering is more effective when humans are involved. The argument is that people who agree on the evaluation of an item in the present or in the past are likely to agree again on the evaluation of another item in the future. Hence, collaborative filtering predicts the interests of items for an active user based on the aggregated rating information of like-minded people in a historical database. Basically, it is based solely on the recorded user-item interactions. So all the interactions that happen between a user and an item when he likes, when he reviews, or when he dislikes that item is the information that is needed, that is pre-recorded for us to be able to implement this collaborative filtering. But there are two approaches to collaborative filtering, which are memory-based approach and model-based approach. Expanding on the memory-based approach, the system employs statistical techniques to find a set of users known as neighbors that have a history of agreeing with the target user. This can mainly be done in two ways. So the approach to memory-based approach, it is also subdivided into two, because there is user-based approach and item-based approach, right? So for the user-based approach, the system evaluates the rating for user U in item I by considering how many other users have showed interest in I, or how many other users have rated I, how many other users have liked I. In item-based approach, the system evaluates the item I by considering how many other shows that are similar to I that the user U has liked. So for us to find the similarity between users, or to find basically to find the similarity between users, we have to quantify similarity into a value. Hence, we can do this, we can quantify similarity through various methods or through various algorithms, such as cosine similarity, Pearson correlation coefficient, Spearman correlation, and mean squared difference. The Pearson correlation coefficient formula is a bit long, but it is as indicated in the video, where RIC is the rating of the item C by user A, and AI is the average rating of user I for all the correlated items. That is for Pearson correlation. And for cosine coefficient, the formula is as below, where RIK is the rating of the item K by user I, and N is the number of items correlated by both users. Then moving on to model-based approach. Model-based approach develops recommendations by developing a method from the user ratings. By developing a model from the user ratings, the model learns and gains knowledge from the pre-recorded user and item interactions, right? Such that it learns a model that can predict and and recommend things that recommend items that the user might like. In addition to using explicit data such as ratings, the system also uses implicit data such as by observing user habits such as browser activity, books read, music played. These are just examples and applications developed. For model-based approach, there are a few ways of implementing the model-based approach. One of which is clustering. Clustering is based on the assumption that users who are in the same group have the same interest. Hence, assume that they rate items similarly, right? the users are divided into groups called clusters, which uh, are defined as a set of similar users in a group, right? The distance between two users has to be calculated either by the Euclidean distance, Manhattan distance, or the Minkowski distance. Assuming that each user is represented as a rating factor denoted by UI, the formula for the Minkowski distance is as follows, as indicated in the document, right? Then we also have the formula for Euclidean distance is also as follows. Then for Manhattan distance is also as follows. So the less distance between users, the less distance between user 1 and user 2 indicates a greater similarity between these users. Right. So one of outlining the important steps in clustering is the first step is partition the users into clusters with a rating value for each user, right? Then two, the active user is assigned to a cluster, and the rating of that cluster is the one that applies to that active user as well. Then we also have matrix factorization. Matrix factorization is whereby a user rating matrix, assuming the user rating matrix M, assuming that the user rating matrix is M, it is decomposed into two matrices. The matrix is decomposed into two matrices, one which represents users and one which represents items. The dot product of these users is approximately equal to the original user item matrix M, right? So basically, we are decomposing this one big matrix into two matrices, so that we have one matrix that represents users and one that represents items. This is mainly achieved through an algorithm called singular vector decomposition, proposed by Simon Funk in 2006. Assuming the user item rating matrix is M, SVD, or singular vector decomposition, defines M is equal to U sigma V plotting. So T is basically the transpose of a matrix. Um, then yeah, so basically what I have done for the algorithm itself is I was able to code the code for the Euclidean distance, because we need the Euclidean distance to find the similarity between two items. We Yes, this function uh, is to measure the Euclidean distance between 2 points. So yes, and then I have a function to split the data such that from the data that I collect, I will have 70% that represents training data, and